Welcome back to More Than Rust. Today is kind of a requested video on how the ignition system works on a vehicle. My basis here is still going to be the Mark 1 Civic I have because it's a good base, it's quite easy to see things on. But this general principle works with most older cars and probably up till late 80s, early 90s stuff. Of the lower end anyway. So, how does sparks work? To the whiteboard! Woohoo! So, basic components that make up an ignition system. You have the contacts, the coil, the distributor, and then the spark plugs. Some of them are self-explanatory, some of them are less so. So let's break it down to step by step and we'll go from there. Component themselves normally lives under the distributor cap. So you take the cap off, you take the rotor off, and under there you'll find the points, the contacts. And the principle of them is quite simple. Basically you have a cam with points on it and a switch. And that's really all there is to it. So the cam in this cap is defined by the number of cylinders you have on your engine. So if you have a 4-cylinder engine, you'll have 4 cam loops. If you have an 8-cylinder engine, you have 8 cam loops. What that really means is a 4-lobed cam is just a square, an 8-lobed cam is just an octagon. So this part here, this little square box I've drawn here, rotates. It's actually really bad drawn right now, but as this rotates, this arm here, which is pivoted, will move in and out. So when this point is pushing on it, these 2 points here, between this contact pad and that contact pad, will connect together, allowing voltage and power to flow from whatever wire you attach to this end. When then this comes around a bit further, this opens back up again, breaks the connection, little ground circuit. All making sense so far? Great. Let's have the next part. So, next part, the coil. This is normally a big cylinder with a couple of terminals on top of it. As the name suggests, it's literally a coil. So inside you actually have a big coil of wire that runs all the way down and back up, and in the middle there's an iron or steel post, effectively. The coil's job is purely to take 12 volt energy and turn it into the 15,000 volts that the spark plugs want to see. Energy, the higher the voltage, the easier it is to jump the gap. The lower the voltage, the less likely it is to jump the gap. So the third component on the ignition system is kind of a twofer. You have the rotor and the distributor cap. The rotor is the thing that spins around the side of it, and that basically points to which output on the cap is going to send the spark towards, and the cap is normally a plastic cover with obviously a post for each one of the spark plugs, and a centre post to take the spark from the coil. Pretty damn simple. Hopefully. And the last main component of the ignition system is, well, the spark plugs. These are the things that actually make sparks out of the cylinder to ignite the fuel air mixture. So, that's the basic 4 components of an ignition system. Let's go and look at the Civic and I'll show you what they all look like on a car. This is obviously the engine inside the Civic. The basic principles we were looking at before is this here is your distributor. It's normally a cylindrical object with, say, lots of wires come off the distributor cap, like I was talking about. Over here we have our coil with a main lead coming out the centre of it, plus the HT lead, and 2 contacts on the face of it for the wiring connectors from the distributor and from the ignition system, or from the electrical system. Try that again. Over here we have the coil, and this obviously has the main HT lead from the centre of it, and the 2 electrical connectors that I talked about on the board before. We'll go over the wiring of all this in a moment. So, got your distributor down here, and inside up here, on most of these cars, you'll have points. So, rotor arm, under here, blow everything off, there are your points. I would show a close picture of those, but on my car, I don't have points. More on that later. And obviously, 4 of them HT leads down, which connects the distributor to your plugs in the engine. It's also quite grubby down there. So, that's the real basics of it. Okay, take it back over to the board, and I'll drop the electrical diagram for this, so hopefully you see how it all connects together. Oh crikey, I've been doodling again. So, here's my crude visual representation of how an ignition system on a car is kind of wired. So the blue lines are normally like thinner wires, 12-volt circuit, and the green wires on here represent HT leads, or basically high voltage spark carrying wires, if you like. So I've tried to blow it up as much as possible, but I'm not sure how clearly it's going to be, so bear with. So I'm running through this. At the top here we have the battery. Positive battery via your ignition switch and everything else in your car, trying to avoid some of the complex stuff here, connects to the positive side of your coil. If you look at the coil, will have a plus and a minus on it. So that takes 12 volts in. The negative side of your coil connects up to the points. Now, I don't know, because I haven't looked back at the footage yet, but I think I drew the points slightly wrong before. The negative side of your coil is connected to your points. When your distributor turns, the points open and close by this cam leg, obviously. So when the cam point is pushing on the arm, it opens the circuit and you don't get any power back through the coil. When it's off that cam lobe, points are connected, power goes from the positive of the battery through this side of the coil, around the wires, back out this side, through this connector, back to the negative side. Normally earthed within the distributor itself, but circuit view so you can see that everything connects back to ground. So, that's that. So, distributor turns around, opens your points. That causes the energy that was stored in the coil to dissipate or discharge, and that energy is then amplified in voltage by the design of a coil, and the spike of high voltage, low amperage energy is shot out of the center post of your coil into the center of the distributor. So, this is how the distributor part works. Is inside you obviously have your rotor. The voltage will come through the center pin into the center of your rotor arm. It will then get, because this is a metal tang on top of it, it'll get taken by this to one of the corresponding posts on top of the distributor. The voltage then comes in, across this, back out of the post, another HT lead, which is the big red ones you saw on my car, into the center of a spark plug, onto the conduct point. Through the center of the spark plug, comes all the way down to the bottom, jumps the gap between the center post and the earthing strap, which is normally like a little foot that sits underneath it, and the rest of the outer piece is grounded, so again that goes back down to the minus. So this here is the only place you really want to get a spark. If there's a spark anywhere else on the circuit, you lose energy. So, everything else must be nice and tight. This wants to be gapped to how your specifications say they should be gapped. Every engine, more or less, has a different gap size. Make the gap too big, you won't get a spark because it won't have enough energy to jump the gap and it will arc somewhere else. Because it will always take the easiest way back to ground. Make the gap too small, you probably won't light your fuel off because it's jumping that gap but not being big enough to ignite the fuel atoms within the air mixture. So that's a real basic principle. Coils are bizarre. So a coil will charge when it's connected and discharge when you break the circuit. So it's actually how I used to get confused with these. I used to think that they would spark when you connected power to them. They don't. They spark when you disconnect power. So for instance, this coil normally just a car sitting there, will charge up because it's got power coming in here, go through the coils, out the other side, through this wire, back to ground. It's only when you disconnect that ground source, or in this case, open the points, that the coil goes, oh, I haven't got power anymore, discharge, and it just dumps it very rapidly. Alright, so let's add some more realistic things. Your ignition system isn't live all the time, there's a switch up here. So, what you normally have is up here somewhere. You'll normally have your ignition switch. Okay, so this here is a real basic crude diagram of how a points circuit works. There's not too much to it. Alright then, so now we've looked at the basic diagram for a point circuit, let's also point out the next glaring, miss on here. You may want to know this, but when you discharge a coil, it sends a high voltage spark, plus the HT lead. However, that bulge of electricity or power isn't only coming out the HT lead end, it also comes on any end of a coil. So that includes down this wire here. It obviously goes into your points. So to combat this, they actually fit what's known as a condenser, which is a single wire unit that's like a little box with an earthing strap on it. So the job of the condenser is literally when you open the circuit for the coil, it doesn't send a spark that way and a spark this way. Because the last thing you need is it to spark down this wire and jump that gap there. Because that's just going to burn your points and damage something. Which brings me on to the next point. These tips here, they wear out. You use a car, they get a tiny spark on them because that's just electricity for you. And it will burn the tips. And they burn enough. There's then no contact between the two ends. Therefore, even when they're closed, the coil ain't charging. All this time, I've been talking about points. This was a very common system to use through the 70s and into the early 80s. However, around this time, you may be aware, electronics started getting smaller and, smarter and a bit, early consumer electronics were cheap enough. So, companies made the switch from points, which obviously wear out and go bad over time, to what's known as electronic ignition. Now what this basically is, rather than having points, you have a sensor here that detects a change that's then used to trigger the coil. The idea being there should be no 12 volt circuitry really down here that's wearing out or going wrong. This is why I couldn't show you points on my Civic over here, because I've actually converted it over. The Civics are really easy to do. There's a few other brands that are easy and not so easy. So the Model Civic was eventually redone as a Mark II Civic, and the engine on the 1300 engine using the Mark II is really the same engine as what's used in the 1200s of the Mark I. All they put on them was electronic ignition, and they bored and structured them out a bit to give it more CC out of them. So that electronic ignition setup for a Mark II Civic bolts straight onto a Mark I Civic. There are a few component changes on here. So first of all, you get rid of this one. Because, that's way too old. What you then end up with is this strange pointy star-shaped thing instead. This is still attached to your distributor shaft, still spins around the same sort of thing, with 4 little points on it. What you have then is a little sensor that sits next to it. That's called a Hall effect sensor. What this detects is a change in magnetic properties nearby. It's a bit of a bizarre system. So what happens is, because this centre spinny star thing is iron or steel, it's magnetic. So what the sensor will detect is when these points come past it, it'll go, oh, there's something magnetic, and send out a tiny little voltage. And it is minute. So what ends up happening is you have, now your negative side of the coil, on this circuit you get rid of. This then needs a 12 volt circuit, so you grab that there. And you then also have on here a ground, like any other system. And then you have a signal wire output. Now this signal is no use to the coil. The voltage here is like 0.1 of a volt. It's not going to be enough to trigger the coil on the car. So you need what's known as an amplifier box, which, say, Civics and the early systems used to use an external box that's, a reasonable size, with normally 3 or 4 wires on it. So it's like a spiky robot. So you had the signal come into the box like this, and what this box does is literally go, okay, this is minute electronic. It's basically a transistor in a box. So what it takes is a small voltage comes in here. It takes a 12-volt feed, which you need that. It takes a nice ground feed, which was either a separate unit or it grounds through the casing, depending on which box it is, depends on how it works. And the final wire is then literally hooked up to your coil, like the old system used to do. So the idea was that now your distributor has this tiny little sensor in it that sends out a tiny little spark, or little signal, if you like, that's very noticeable most of the time. It goes into this box, and what this box does is it goes, okay, I've sensed a signal. What I will do now is, when I sense that signal, I'm going to disconnect the coil from ground, and therefore what same way as a coil does. It's been charged, disconnects it, turns off. Anytime it's not detecting a signal, it will put power from this wire to this wire. So it's really quite a simple circuit in itself. So, advantages of electromagnetic over points. Well, the biggest one is there's no points to burn or wear out. So that's a good advantage. The other one is you also get a slightly stronger spark, and that's because there's more energy density in it. It's a lot more accurate, and that's good for high moving engines and stuff. Biggest disadvantage of these, they can just stop working. But literally out of the blue, they can just don't want to work today. 90% of the time, it's amplifier box that dies. You can now buy universal amplifier boxes because, what I say, all it needs is a signal from the distributor and then the wiring for positive ground and coil. So it's not a major disadvantage. They're harder to fix on the side of the road. So as you can see, we're back on Civic. Here's my rotor arm, poured over clean, but say metal tang all the way down from the centre point out to an edge. And obviously here's the inside of my distributor. Okay, so this is my pickup. This is the main pointy star thing I pointed out before. And these towers here are actually the pickups for detecting when it comes round. So this signal is then sent up these 2 wires. So again, the negative on my unit goes through the body of the distributor itself. Positive comes down the red wire, that's my 12-volt feed. And my signal wire is my purple wire here. Blue wire. See it clear there. So that blue wire there is the signal from the pickup. That runs into this little box up here. Now, it may look quite complicated because you don't have wires on this thing, but some of them aren't used. So, the signal goes in. I've got a 12-volt feed taken from the coil that is then used, as well as obviously it grounds through a ground wire that runs back over to the base of my coil. And obviously you've got an output wire from here that goes to the negative terminal on my coil. And so that coil part there replaces the point system that would have originally lived in this distributor. So I hope you enjoyed this relatively quick video about the ignition circuit on a car. This was actually a suggestion from someone who messaged me from a Mark 100 Civic group I'm part of on Facebook, and I'm more than happy to take other requests from other people. Flick them over to me in the comments of this video or whatever, and I will look at them, and if I know what or how the thing works, I can try and do one of these simple videos to explain it to the rest of you guys. I already have plans for a couple of videos similar to this format, one of which is on the carburetors and how they work on an engine. Again, try and keep it quite basic with lots of information. And the other one is how to time up the engine once you've wired up your ignition system. Both of those might come out in the next couple of weeks or so. We'll see how I'm doing time-wise. Other than that, I hope you all have a good one and enjoy the video. And do leave a like, leave a comment, subscribe to the channel if you're feeling really snazzy. And I hope to see you all guys in the next ones. See ya.